later that you decide that it runs parallel with the straight line?
You won't, well, you won't always be given a straight line over there. Because remember in the problem that we did before, the two curves came together at a point? Then you don't have a straight line for reference. I know what you're saying here. You're saying, like here, it's a straight line here. So do a vertical rectangle. But what if you had something like this and you want the area here? Do you use vertical or horizontal? So you don't have a straight line as a reference. I'm just afraid to say, like, if you see a straight line, always do parallel to that, because that won't always be the case. So it's more about thinking about the way that I've explained it to you is the way it makes sense to me. Is when I'm trying to figure out if I'm doing vertical or horizontal, I'm looking at, as I move my rectangles through, how complicated is it? Like, I always have the red on top, blue on the bottom. That's great. If I do this way, it's not like that. It changes, right? That's what's dictating it for me. All right, since these are functions of x, let's solve these. Let's not solve them, let's write them as functions of x. Let's see, f of x equals sine x is my blue one. My red one is g of x equals x, right? Oh, I got them backwards. Is that okay that I got them backwards? That I labeled them this way? You can call them whatever you want. You just got to remember when you put your formula together, it's going to be this top one minus the bottom one. Okay? Top minus bottom. That's all that matters. This distance, right? What's that distance from here to here? For us, the way I drew it, it's g minus f, isn't it? I don't want you getting locked into a formula, like it's always f minus g. It's the geometry is what you're going off of, the picture, what you see, right? What I see here is my red's on top, my blue's on bottom. What's the red one? G of x, so that's x, right? And I'm subtracting from that the blue one, which is sine, right? There, that's my height of my rectangle. And then the width is dx. Do you get what I mean? Like, don't be fixated on, formula is f minus g. It's not. It's top minus bottom. If you want a general formula, it's top minus bottom. Okay, so here's what I know so far. Integral x minus sine x, that's the height, times the width, dx. And now I need to go and start my rectangles at the left and end at the right. What was the left? Where did that come from? Do we know where this left was? That was pi over 2, and it ends at pi. See, that's what those two vertical lines gave us. They gave us our limits of integration. We actually don't even have to solve for these. Pi over 2 to pi. Okay, done. We're not going to move. We're not going to do that problem. We're not going to. We could do that, right? Antiderivative of this, 1/2 x squared. Antiderivative of sine, cosine, well, negative cosine, blah, 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 and then, yeah. All right, so we could do that. Plug in pi over 2, get an answer. All right, now, you ready to see how to do this on the calculator? All right, so what I'm about to show you is going to be extremely useful when we get to some problems here in a second. So I need you to let's just kind of take a pause, take a step back here, and we're going to talk about something this is a separate topic, but related to this, but separate, all right? We're going to talk about parametric equations. Now, we are going to revisit this at the end of the semester if we have time. This is chapter 9, all right? Chapter 9. Normally, I don't get to it, but I have videos and I say, hey, go watch it if you want to. Later on, you might need this later. All right, parametric equations. So let's go look at this equation right here. Y equals sine x. Okay, we all know that this is a function of x, right? This is a function of x. We could rewrite this as f of x equals sine x. And we know how to type this into the calculator, and the calculator will graph this for us, right? No problems. When we're first learning about functions of x, we do this thing called a t-table, where you take x here, and then here you get the y, or the function's value, right? So like if I said plug in 0, you plug 0 in for x, and it spits out some value, right? 0. If I say plug in another number, it spits out another number, right? So this is x goes in, y comes out, right? X goes in, y comes out. All right, great. Wonderful. I'm contemplating how I want to go about this, all right? So when you plug in an x here, the output comes here, right? That's your y value. And so this point is just some x and some y. I know I'm like restating the same shit over and over here, but I just want to make sure we're completely 100% clear. Yes? All right, that is a function of x. Now, let's look at a function of y. So what if I said the reverse of this? I switched these. So if we made a t-table, what would be your in and what would be your out? The in would be the y and the output would be the x, right? And so you put some values of y in, 0, sine of 0 is 0, we get this, and then we could continue doing that, right? And we get the graph. What does the graph look like? Well, this graph, anyone know what it looks like? It goes like this. It's a sine function going along the y-axis instead of down the x-axis. That's the graph. The important thing, distinction here I want you to see here is that for each of these, right, both of these graphs, this one you plug in x, it spits out y, right? This one you plug in y, and it spits out what? X, right? But at the end of the day, they're just points, aren't they? This is an x and a y coordinate, this is an x and a y coordinate. The difference between the two is that here you plug in x, get y, here you plug in y, you get x, right? It's the only difference between those two ideas. So we're going to talk about now this thing called the parametric equation, which does this. It eliminates us having to make one of these be an input and one of them be an output. Instead of forcing one of our two variables to be in and the other one out, it allows us to use a separate variable as our input, and the output we have two things that come out, okay, instead of one thing that comes out. Here, one thing goes in, one thing comes out, right? One thing goes in, one thing comes out. With the parametric equation, what we're going to do is this. Parametric. Just let it develop here, okay? If you're confused, just let this idea develop. Parametric, what we're going to do is this. Is our input is going to be some variable called t. It could be anything, but we usually use t, all right? Our input is t. And our output is going to be a point, okay? So here, what was the input? Was x, and the output was y. Here, the input was y, the output was x. Here, the input is some variable t, which we use t because we can look at it as like time, like a clock in the background. And the output is some x and y coordinate. Now, the x coordinate will be some function of t, and the y coordinate will also be some other function of t. So what I'm going to do is I'm going to plug in a value of t. Let's look at it like a t-table. I'm going to plug in a value of t, and then what I'm going to get out is a point. When I plug in t equals, I don't know, some value, I'll say t. What comes out is this point where the x coordinate is the f of t. It's whatever this function is. The y coordinate is g of t. Now, I think the best way to illustrate this is with an example, all right? So what I'm going to do right now is I'm going to graph this function right here, this one. I'm going to graph it, but I'm going to graph it using this instead of this. And I'll do it next to here. I'm going to erase this one. Here's the way I'm going to define it. So the thing you have to define for parametrics is you have to give me this information right here. You have to tell me what f and g are. So I'm going to tell you right now that x right now is t and y is sine of t. Now I'm claiming right now that this is the exact same graph as this. The pictures look exactly the same. Exactly the same. Well, do they? Do they look the same? Think about it. If I'm telling you that t is x, right? If I'm telling you that t is x, then what happens if you replace that t with x? What do you get? Y equals sine x. Isn't that equation?
Yes.
Yes. So now if I do a t table, let's plug in a value here. Let's plug in 0 for t. What would you get here? Okay, what's 0 here? 0? What's sine of 0? 0. Okay, let's do another point. Let's do pi over 2. If I plug in t equals pi over 2, what do we get? Pi over 2 here, and sine of pi over 2 is 1. What I just did was I plotted this point. When you plug in 0, you get the point 0, 0. When you plug in pi over 2, you're up here at 1. And as I keep on plugging in different values of t, I get more points on the sine curve. Okay? Your calculators have this ability to do parametric equations. So that's what I'm going to bring up right now. On my calculator, I have to go turn it on. There it is. Okay, so what I have to do to make this work is I have to go to mode on my calculator. And when you go to mode, there's this thing here that says func par pol seq. So that's function mode, parametric mode, polar mode, and sequence mode. We're going to switch it to parametric mode. So we just move to the right, no, down, sorry. Move to the right and hit enter. Highlight over para, hit enter. And then, after you hit enter, you can just hit escape. Well, I don't even know if I need to hit that. Go to the y equals, like you're going to go graph a function now. And what you'll see when you get to this mode, or when you, that was weird. What you'll see here when you get to this screen is instead of seeing a place for you to put in these functions of x, like we did, like normally, you'll see it says x1t equals y1t equals x2t, y2t, right? These are pairs, okay? And this right here, this right here is your x1, y1. So what I need to tell my the calculator is I want this to be t, and I want this to be sine t. So I'm going to use, I can still use that xt button. It'll know that I'm in parametric mode. It'll put a t in there. So right here, I'm going to put t. Boom, there it goes. Then I hit enter, and then I'm going to hit sine t, and then hit enter, and now I'm going to hit graph. And let's go back to Zoom standard here. You'll see it? It graphed.
I got an error.
Okay, I'll have to look at it. Yeah, just for now, just let me keep going. Can you all see that that's kind of a little piece of the sine curve? It's not the whole thing, is it? Okay, we can adjust the window. So I'm going to go to window. And when I do window, do you see where it says T min, T max? That's this T, right? My input. By default, on these calculators, by default, when you're in parametric mode, it always goes from 0 to 2 pi. Because they figure you're probably doing something with trig functions. So if we change that window, change it to -10 to 10. And it's going to look exactly like your regular function mode. -10 to 10. and then hit graph again. And now you'll get the whole sine curve. Okay? Y'all follow me? Now, let's see if you, I'm looking at y'all, a lot of y'all look very zoned out. That's okay. Let's see if you really understand this. I want to see, can we use our calculator to graph this? Because you can't do this in the regular mode on your calculator. You can't, right? You cannot. This is a function of y, right? Not a function of x? Okay, but we can do the same sort of thing we did here. Can I go and make a parametric? Yes. This time, I want my x to be sine of y, right? So I'm going to replace the y with t, and the x will be the sine of t. And now do you see that if I take this t and replace it with y, we get sine of y is x. And so let's do that on the calculator. I'm going to go back to where I can type things in and switch them. I'm going to leave these here. Okay, I'm going to leave both of those there. I'm going to go to the third line, and I'm going to put in sine of t here, and then t for the y coordinate. And if I switch those two and hit graph, I've got my function going the other way. Do you see that? The calculator's not thinking about functions of x anymore. It's thinking about this parametric idea, which means technically you can graph any function of y using this. Anything. How would you graph this? I'm going to leave that on the board. How would you graph this? If I said, okay, graph x is the square root of y plus 1. What would x be? What would y be? This is square root of t plus 1, and what's y? T. What if I wanted you to do x equals y cubed plus cosine y? Okay, well then x would be t cubed plus cosine t, and then what would y be? T. So in other words, anytime you want to do a function of y like this, you just, in the x, you put that function of y, but you change it to t. And then for y, you just say t. And anytime you would want to do a function of x, you'd let the x be t, and you let the y be that function of x, but replace the x with t. In other words, parametric mode, like if you really understand it, you actually don't need the other mode anymore. Like you really don't need it, because this mode's more powerful. I hope that kind of makes sense. I'm trying to give you all a way to graph on your graphing calculator, be able to graph something like this. All right, y'all ready for me to put this up? How much time we got? Yeah, let's see if I can do this on my calculator. So I'm going to go back to y equals. Let me delete this. Let me delete that one, clear that, clear that. So right now we've got the sine curve, right? We've got the sine curve. Now I need y equals x, right? How are you going to do y equals x? How do you graph y equals x using parametric? So you let x be what and y be what? T and t, right? T and t. You let them both be t, and you're going to get y equals x. So I'm going to go here, and let's go t, and then t. That should get us the red one. How do we graph a vertical line that goes through pi over 2? So that vertical line is x equals pi over 2, right? So go to your parametric, and you want your third x to be what? Pi over 2, and what do you want your y to be? T, right? That'll draw it. So I'm just going to type in here, where's my pi? Pi divided by 2 for my x coordinate, and for my y coordinate, it's just going to be t, which will draw me just a bunch of points that go up and down through pi over 2. And then for the other vertical line, I want my x to be pi, and I want my y to be t. And now if I hit graph, I should get the sine curve. See it? Here comes the line. Here comes the first vertical line. Here comes the second vertical line. And now I can zoom in to that region that I see and hit enter. And I should have something similar to this. Okay, yeah? Okay. I hope that, I mean, I know a lot of you don't have your don't have calculators with you and stuff, and I should have told you to bring them, but, you know, you can always go back and look at this video if you want. If you have questions, you come see me about it, all right? I think this is pretty awesome. We have a way of graphing anything, functions of x or y now, right? Let me see what our next example is, and I think I might just call it a day. We're not done with this section. Yeah, this is a great example of why it would be nice to be able to use that function on your calculator, right? We'll pick up here next time. There's still a few more examples that we need to do. I would say for right now, let me look at the homework assignment, and I will send you an email today to tell you what problems to do. I want to make sure I avoid a few. You have everything you need to do the problems. I just haven't given you a bunch of examples yet. So there's nothing like some new idea. We just need to do more examples. But I'll look at the homework and I'll say, okay, you know what, do these, just wait on these, because those are a little harder. And then also the corrections, right? Make sure you work on your corrections for your test. Everybody have a great, what is it? Are we going to say weekend? Yeah, yeah. Yeah, it's Wednesday, right?